Hello everyone, welcome in Learn CHE. In this video, we are going to discuss about unit operation. What is unit operation? We can see that unit operation is a backbone of chemical engineering. Okay, if I say unit operation is everything for chemical engineer, so your answer should be yes. Okay, and if someone say to you that unit operation is everything for chemical engineer, so you can also say yes, right? So what is a unit operation, we will see in this video, and in our upcoming playlist of unit operation we will discuss each unit operation in detail. So in an industry you will see any chemical process, right? I am talking about the chemical process here, may be a combination of series of unit operations, right? Unit operations and unit process. So what is the difference between unit operations and unit processes? Is the unit operations are those operations which involve physical changes, right? Here a physical changes occurs. What is that means? Here you can simply see that one thing, okay, is converted into another. Like if I talk about distillation, distillation is an example of unit operation where the liquid mixture is crude oil, right? Crude oil is converted into LPG, petrol, naphtha, kerosene, lubricating oil. This is an physical change where you will not see any chemical reaction, while in unit process involves chemical changes. Example, any reaction involves unit process. Example for combustion, right? So for example, a distillation of crude oil is an example of unit operation. The production of ethanol from a solution involves unit process. So this is an example of unit operation and unit process. Unit operations are caused by the transfer of energy. So what is that means? It means that energy transfer from one side to another side, and because of that it can be classified based upon the modes of energy transfer, right? So how or the types of unit operations are mechanical operations, right, and thermal operations, electromechanical operations. Okay, and we will discuss each unit operation one by one. Let's see. Here are the examples of physical changes and chemical changes. Here are the examples of physical changes and chemical changes. In physical change, you will see here, suppose the ice, right? So water can turn into ice and ice can reverse into water. Okay, so this is a example of physical change. But in chemical change, suppose this is a burning of wood, okay, the example of combustion, or rusting of iron. What happens there? There a chemical reaction happens, right? That's why this is a chemical change. Same thing happens with unit operation and unit process. In unit operation there is a physical change, and in unit process there is a chemical change will occur. Okay, like here you can just see the difference of unit operation, where distillation you can see the here batch distillation, and in combustion which is a example of unit process, and you can see one example of combustion here where 1 mole of methane is react with 2 mole of oxygen and it gives carbon dioxide plus water plus heat energy, right? So this is an example of unit process. Next we are discussing about the unit operations, right? So we will discuss each unit operation one by one, and the first unit operation which we will discuss, that is mass transfer operation. Okay, so mass transfer operation is a unit operation. Okay, and we also see that, or we also say that it is a chemical operation, right? I'm not saying that it's a chemical process. No, it's a chemical operation. If someone say you, or if you say someone that mass transfer operation is a chemical operation, maybe he will confuse, or he or she will confuse, but you have to say completely that I am talking about chemical operation, not a chemical process. Okay, chemical operation where chemical changes not happen. I am not talking about here chemical changes. I am talking about here chemical operation where we see the presence of concentration gradient. What is that concentration gradient? That concentration gradient is an driving force for mass transfer operation. What is the meaning of driving force? If you know what is the meaning of driving force, then let me in comments box. Okay, so where we see the presence of concentration gradient within the fluid consisting two or more components. Okay, so for example, crystallization of sugar from a sugar solution. Okay, from a sugar solution, what we do, we get a crystals of sugar with the help of crystallization. Okay, we heat the sugar solution and we get the crystals of sugar, is an example of mass transfer operation. We will also discuss about crystallization later, but this is an example of mass transfer operation. Distillation, liquid extraction are the example of mass transfer operation. Why? Because the difference of concentration gradient. Okay, the concentration gradient is a driving force for mass transfer operation, and if I talk about true driving force, then we say chemical potential is a true driving force for mass transfer operation. Okay, so like here you can just see the example of mass transfer operation. Here is a combination or a mixture of gas A and B. Okay, I am talking about A and B. So you will see here, this is A, suppose this is A and this is B. So what you are seeing here in this box, okay, I have separated this box by this partition, right? So what is happening here? Here is A and B mixture of gases, same this side left side and this is a right side and this is left side. Okay, here the combination or here is the concentration of blue gas is higher and orange gas is less. In right side, here is a concentration of orange gas is high and blue gas is low. When I'll remove this partition, then what will happen? Because of the concentration gradient, what will happen, that the gases will transfer from one side to another side. One side to another side means higher concentration to lower concentration. Okay, like this is a blue gas, right? Here the concentration of blue gas is higher, so it will go into this side, means right side. Same, the concentration of orange gas is higher in right side, so it will convert in or it will go into left side, right? So after the equilibrium, okay, what will happen, that the orange gas will be appear here and the blue gas will be appear here. This is an example of mass transfer operation. Okay, I hope you understand this, what I want to tell you about the mass transfer operation. Mass transfer basically occurs due to difference in concentration gradient. Okay, so it will go from higher concentration to lower concentration. So the first mass transfer operation is distillation. What is distillation? Distillation is a unit operation whereby a liquid components, I am talking about the liquid components, are separated from a liquid mixtures. Okay, let's see the example of this, you will understand better. A crude oil is a liquid mixture here, right? And the liquid components, these are the liquid components: the LPG, gasoline, kerosene, diesel, fuel oil, lubricating oil, wax, paraffin, etc. These are the liquid components which we separate from crude oil or petroleum with the help of distillation column, right? So how? By partial vaporization. By partial vaporization, what happens there? Due to difference in vapor pressures, right? Here the vapor pressure of LPG, the vapor pressure of gasoline, kerosene will be different, and due to this difference we get LPG here, kerosene or gasoline here, and kerosene here, diesel here. Okay, so due to difference in vapor pressure we get the different components at different place in a distillation column. So the concentration of the more volatile component of the liquid mixture is higher in the vapor phase. What is that mean? While the concentration of less volatile component is higher in the liquid phase. What is that mean? The concentration of more volatile component means, okay, so the concentration of more volatile component of the liquid mixture is higher in the vapor phase, means that component which has a higher vapor pressure will be present in vapor phase. Okay, and the less volatile component means which has less vapor pressure, okay, will remain in a liquid phase, right? So that's why you will see naphtha here, that's why you will see lubricating oil here or residues in a bottom section of distillation, and LPG at the top of the distillation column. Okay, now the next mass transfer operation is liquid mass transfer operation. Okay, so in liquid extraction, what we see that we separate liquid right? We separate a liquid component from a liquid mixture. Okay, suppose there is a liquid mixture and we separate one liquid components from there with the help of solvent. This is called liquid extraction, where okay, so let's see here where one or more liquid particles are separated from the liquid mixture with the help of liquid solvent. That's why this is known as the solvent extraction. Okay, a solute in a liquid solution is removed by contacting with the liquid solvent. Okay, the solute, what is the solute which is a desirable for us, that is solute in a liquid solution. Okay, and just see here the liquid solvent which is relatively immiscible, which the liquid solvent which has to come in contact with carrier liquid, right? So the solute rich phase, where the solute concentration will be high, is called extraction phase, and the solute less phase, where the solute concentration is less, is called the raffinate phase. Okay, the example we can see here, for example, in extraction, suppose this is a feed where A and C are the components. Okay, and C is desirable, which means we have to extract C. Okay, is extracted from the feed containing carrier liquid A and C, right, by using another liquid solvent B. So what we are doing here, this is our like a column where what we are doing, a feed is going into this and the solvent is going into here. So what we get a mixture, M. Okay, after the extraction, what we see here in a raffinate phase, where the concentration of A is higher, okay, concentration of B is less, and concentration of C will be also less. Okay, I'm not saying that it is a completely immiscible. It will not be a completely immiscible. You will see some portion of some concentration in raffinate phase as well, but due in a calculation we can avoid that, but in a industry we consider that, right? And in a extraction phase, right, in a extraction phase here you will see the concentration of B and C is higher and A is very negligible, or you can say in a very small portion. Okay, so extraction phase is that phase where B and C is higher, and raffinate phase is that where A is higher. This was the example of liquid extraction, or let me in comments box the example of liquid extraction in a industry. Now the next mass transfer operation is drying. So what is drying? Basically the separation of liquid mixture or liquid moisture from the wet solid is known as the drying. Okay, this is the last operation of any industry. In any industry, drying is the last operation. Okay, the basic example of drying is our wet cloth. When we keep our wet cloth in an atmosphere where sun absorbs the moisture from our wet cloth, and after some time we get the dry cloth, is an example of drying. Okay, so there the mass transfer is happening, there the drying operation is happening, right? It involves the removal of water moisture, you can say, at temperature below the boiling point of water by circulating air or some other hot gases. In industry we use circulation of air, okay, air and some other hot gases which remove the moisture from the wet solids. Okay, so in drying operation heat is supplied to vaporize. What we do? Vaporize the water to get our dry solid, right? So these are the, like, this is a tray dryer which you will see here. These are the trays where we put our wet solids, and then we close this and set the values, or like after 15 minutes, 10 minutes, and we get our desired product after some time. Okay, these are the trays which we use, right? Or you can see here the diagram where this is the dryer where the wet solid is going, and from another side the dry air is, we are providing dry air. So after the complete operation, what we get, the desirable product is dry solid, and here what we get, the wet air. Why wet air? Because the wet solid which came from here is come into contact with dry air, and so dry air extract moisture from wet solid. Okay, so and we get dry solids from here and the wet air from here, right? This is an example of drying. Now the next operation is absorption. Okay, this operation is also known as liquid gas extraction and defined as the separation of vapor solute. Okay, vapor solute in a gas mixture. Vapor solute in a gas mixture is absorbed by liquid. We can say liquid here as a solvent in which the solute is more or less soluble. Absorption is generally carried out to reduce the concentration of pollutants, means, or toxic substances. Means we use absorption there where the in that industry mainly where the pollutants or the gases are not good or not beneficial for the environment, that's a very toxic. So where we use the absorption tower, okay, to remove the pollutants. For example, okay, so here is one example of absorption which you will mainly see in a table, that is absorption of ammonia from a air ammonia mixture. Okay, suppose you have a air ammonia mixture and you contact that mixture with water. So water is basically here work as a solvent and is the example of absorption. Okay, so after some time you will see that the ammonia comes in contact with water and air is separated. Suppose this is a absorption tower. This is a absorption tower. What happens there? The liquid inlet from here, suppose this is a counter current operation, right? So water comes from here and water goes from here, water outlet, and a liquid mixture, okay, a liquid mixture of air ammonia comes from here and it contacts within absorption tower. So what will be the direction? So direction will be this. Why? Because the liquid mix, the gas mixture air ammonia converted ammonia connect, or we can say the ammonia leave air and mix with water, okay, and it goes into, and we get water and ammonia from here. Okay, our desired product we get from here. This is the example of absorption. Okay, and the dry air or the air we get from here. Now the next mass transfer operation is humidification and dehumidification. By the name you can understand humidification means where the humidity will be present. Okay, like example we can see simply. Okay, so first see the definition of humidification. Adding the amount of water vapor in the atmosphere is called the humidification, and the removing the water vapors from the atmosphere is called the dehumidification. Okay, means what is the humidification? Humidification is the adding the water vapor. Okay, we can also say that the increasing the water vapor into the atmosphere is called the humid, and dehumidification is a reverse of humidification. Okay, it is an liquid vapor mass transfer operation. Why liquid vapor? Because you will see here only two phases. One phase is liquid and another phase is vapor, or you can say liquid and gas phase. Here we deal with the mixture of air and water vapor mainly. Okay, whenever you will study humidification, you will discuss air and water vapor mixture, and that mixture we consider as a ideal gas mixture. Okay, so whenever you will study humidification, you will only discuss about water and air mixture. Okay, and then you will study about the dry bulb temperature, wet bulb temperature, saturation temperature, relative humidity, psychometric chart. Okay, with respect to air water mixture. Okay, it was the humidification and dehumidification. Now the adsorption. What is adsorption? Adsorption is a solid fluid mass transfer operation. Means here will be the one phase will be solid and another phase will be fluid mass transfer operation. In adsorption, the transfer of solute which is desirable, you can say, takes place from fluid to solid. Means the direction of separation from fluid to solid. Okay, the example of adsorptions are purification of water by activated carbon or charcoal. Okay, the another example is removal of mixture of air by using silica gel. Mixture from air with the help of silica gel is an example of adsorption. Mixture means you can say the impurities. Suppose this is a adsorption tower where water vapor and air. The mixture of water vapor and air is present here, and it's fed into the adsorption tower, and here is just activated silica gel which comes into from this side, and what we get the dry air. Okay, so what is the function of activated silica gel? If you know, then let me in the comments box. Now the next thing is crystallization. Okay, this is another mass transfer operation which you will see in the industry, mainly in a sugar industry. It is the process where solids particles are formed. Okay, we are talking about the solid. We are the forming solid particles are formed by the liquid solution. Okay, and it comes under solid liquid mass transfer operation. Means here will be one phase will be liquid and another phase will be solid. In crystallization, the solution is concentrated and usually cooled until the solute concentration becomes higher than its solubility at that temperature. What does that mean? It means that in crystallization, the solution, okay, we concentrate the solution, we increase the concentration to get the crystals, okay, and then we cool it to get that crystals at a room temperature. Okay, so that crystals or a crystal formed an impure solution is itself pure unless the mixed crystals occur. And for example of crystallization, you can just simply see the formation of sugar crystals from sugar solution is a main example of crystallization. Now the next mass transfer operation or unit operation is leaching. Okay, so what is leaching? Leaching is a solid liquid mass transfer operation. Okay, and it is also known as solid liquid extraction. Okay, that was liquid extraction because there were liquids. Okay, the mixture was also liquid and the solvent is also liquid. But in this case, in a leaching case, you will see one phase is a solid and another phase is a liquid. Like the example of extraction of oil from a soybean seeds with the help of hexane. Hexane is a solvent which we use here. Okay, is an example of leaching. Suppose here is soybean seeds which we fed from here, and these are the from this side the solvent come into this tower, right? So what happens here, you will see after the operation we get the oil in a extraction phase and cake in the wet cake, basically in a raffinate phase. Means the solute of the desirable content is oil, okay, which we can get from here, and the cake concentration along with negligible concentration of oil which we get from the raffinate phase is the example of leaching. Next unit operation is heat transfer operation. Okay, there is a separate subject of heat transfer you study in your chemical engineering curriculum, or this is also a unit operation. So what is heat transfer? Basically, heat transfer is the study of transfer of thermal energy from low temperature region to high temperature region, same as mass transfer operation. In mass transfer is the study of transfer of concentration, okay, and the mass from a higher concentration region to lower concentration region. This is due to temperature gradient, and that one due to concentration gradient, right? Now let me in a comments box what is driving force, okay, and the heat transfer often occur in the combination with other unit operations like distillation, drying, crystallization, etc. Because you will see in all three operations there is a heat transfer. Okay, there will be a heat transfer from higher temperature to a lower temperature due to temperature difference. Okay, and in heat transfer we mainly study about the three modes of heat transfer. The first mode is where we discuss about the conduction, okay, and here we study the Fourier's law. Then convection, where we study the Newton's law of cooling. Then thermal radiation, where we study about the Stephen-Boltzmann law, right? As well as in heat transfer we study about the phase change, where we discuss about condensation, evaporation and boiling, right? And then we discuss about the design of heat exchange equipment operations and design of evaporation as well, right? Evaporators mainly you can say. And we will discuss about heat transfer in details later, or in our upcoming videos we will discuss about heat transfer or every modes of heat transfer in a detail. So you can see here a simple example of heat transfer operation. This is a heat exchanger, right? So what is happening here, you will see the from one side steam inlet and from another side process fluid outlet. Okay, and you will see here the steam inlet from here and steam is going out from here. This is the outlet. Same the process fluid inlet from here and the process fluid outlet from here. What happens here, the energy transfer means steam which has a high temperature, process fluid inlet which has a low temperature, or you can say the temperature of this one is low and the temperature of this one is high. So the energy transfer, heat transfer, then after the outlet or in an outlet, the process fluid outlet has a higher temperature than process fluid inlet, and the steam inlet temperature is higher than steam outlet temperature. This is the example of heat transfer operation. Now you can simply see here the conduction, heat transfer, that is the mode of heat transfer, then the fundamental of radiation. These are the two examples of modes of heat transfer, where you see that in conduction we study about the Fourier's law, and in radiation we study about the Stephen-Boltzmann law. You can just pause the video and note down everything which I have written here. Now the next is mechanical operation. Okay, by the name you can just understand is we are talking about the manual things, and we are talking about something related to machinery, related to manual operations, right? So the first, like you can say, the first thing which we study in a mechanical operation is transportation of materials. Okay, that come into mechanical operation. So it is one of the most important unit operation in any chemical process industry or in any industry. Okay, in any industry you will see the transportation of material, because the flow of fluid is important everywhere within the industry, and to handle fluids it's much easier than or cheaper than solids. Means if you have to transfer solids from one side to another side, or you have to transfer fluids like liquid and gas from one side to another side, so liquid and gas are much cheaper and easier than solids. Okay, so what a chemical engineer do, a chemical engineer prefer to handle everything in the form of liquid solution, in the form of suspension. Okay, with the help of pipelines. Okay, so in pipeline consists valves, pumps, etc. are used in every industry to convey fluids from one point to another point. You can just simply see, if you have ever visited in an industry, so you can just relate these things which am I talking right now. Okay, so for example, if I or you want to transfer any liquid gas from one side to another side, okay, in a plant from one side to another side, then you will be required pipelines, okay, which connect both points, means one point to another point. And the valves, what the valves do, it regulates the flow, and the fittings which give the proper direction, okay, is an example of transportation of materials. Here you can see the piping system. Okay, this is the very beautiful example of transportation of materials. Okay, without transportation of materials it is very or impossible to convey liquid from one side to another side in a easier and cheaper way. Now the next thing is mechanical separation. That is also another most important thing in many industry, like cement industry and another crushing industry. This operation is prominent, okay, most important. So it is defined as the mechanical separation. Mechanical separation is the separation operation using mechanical and physical forces acting on solid particles and liquids comes under mechanical operation. Means if you have to separate liquid solution, if you have to separate solid particles, okay, it comes into this category with the help of mechanical and physical forces. To reduce the size of coarse particles into small ones, then we use a suitable mechanical operation as per our requirement. Okay, this is an example of mechanical separation. Let's suppose if you have ever seen a sugar cane, okay, sugar cane machine, that's a roll crusher where we get the juice. This is an example of mechanical separation. The logic behind is mechanical separation. Why we do? Because we want a liquid with the form solid. What we do? We use a roll crusher to get that liquid. And suppose if you want to reduce the size of coarse particles into small one, then we use the crushers. Okay, just say am I using here jaw crushers if I want to reduce the size of the coarse particles into small one. And if we want to get fine particles, if we want to get more fines, okay, the finer particles, then we use the grinding operation using hammer mills and another mills like ball mills, hammer mills, tube mills, etc. And the most example and another example of mechanical separations are filtration, screening, settling, okay, sedimentation, mixing, etc. are the examples of mechanical separation. Okay, and listen, this is a jaw crusher. Okay, in a laboratory, that's the jaw crusher, where this is the motor which connect that motors. Okay, this motor is a connect with from this side, which is not visible right now. So this is a hooper where we put the or feed the coarse particles, and from here, from this side, we get the fine particles or reduced particles. Okay, roller, right? The one is fixed and another is movable. Okay, and with movable with the help of this motor, you are seeing this motor, with the help of this motor, the one roller is movable and another one is fixed. And when we put the coarse particles from here, it reduces that side, because that crusher is very hard because of the construction, because that made by the material of steel and iron and etc. and the coarse particles is converted into the fine ones. Like you can see here the vibrating screen. Okay, this is an example of vibrating screens, where what we do, suppose there is a mixture of solids and we want to get the fine solids. Okay, and we want to remove the coarse particles from that mixture. So what we can use the vibrating screen. This is a vibrating screen, means it vibrates. Okay, and the mixture, the solid mixture is here, and we get the finer particles in the next screen. And there are also many screens. Okay, so it depends upon our requirement that how much fine particles we get from that mixture. So what happens here, these are the small mass sizes. What happens there, the coarse particles remains here and the small particles goes down from here. Okay, you can also read what I have written here by pausing the video. And this is the example of ball mill. In ball mill, there are the big balls. Okay, and when we put our feed here and when we start the ball mill, then it revolve clockwise or anti-clockwise, and due to these balls, okay, what happens that the cross particles is convert into the small ones or fine particles, right? So these are the example of mechanical separation processes. Okay, and there are many examples which I haven't discussed in this video, but there are many other examples as well of each operations, like mechanical operation, in heat transfer operation, in mass transfer operation. So what you have to do, you have to study you can study the unit operation of chemical engineering by McCabe. That's a very good book for a chemical engineer. Or we will also discuss each unit operation in a detail in our upcoming videos. So if you like that video, you can just like the video, and if you do not like, so you can dislike. Or if you get something knowledgeable here, so you can subscribe our channel and share as well. So for today, that's all. We will meet in a next video soon. Thank you.